Hi, I'm Noah Wimmer, an application engineer for DG Logic IoT, a division of Acuity Brands. Today we're going to be building a map of Los Angeles that displays available parking spots. We will be using an API provided by the City of Los Angeles for public consumption and our new ESRI map component. This will be a good example of how we can render information using latitude and longitude to display markers based on their location. So this is got a lot of moving parts in it. So I have front loaded the assets we'll be using, the images, and I've also uploaded some symbols that I built earlier that we'll be using to render the parking spot information in the nav bar and on the map. So let's go ahead and get started. Go to our outline and we'll insert our ESRI map component. Let's go ahead and full size it and then move down to LA because that's where our information is located. Okay. And let's zoom in. And now let's go ahead and set our latitude and longitude by hitting enter. So now we're saving these settings so that next time it opens, it will be in this location. All right. So the first thing we need to do is hit our API and bring in the data that we will render. Every ESRI map comes with this generic table of major cities' locations. We don't need it, so we can go ahead and delete it out so we don't have extra clutter on our data flow. And now we need to get a string loader to hit our API. Let's go ahead and grab the API that we'll be hitting, the path, paste it in, and let's get a JSON parser to convert this into a table that we can consume in our dashboard more easily. Oops, parser, not a loader. So output to input, and as you can see, coordinates are hidden inside the JSON in a nested layer, so we need to dig down into them. So they're in a code called coordinates. We will drill down into coordinates, and now when we look at our table, we will see that we have these tables of points. So we need to dig those tables out, the points out of those tables, and add them to our table. So to do that, we will use a repeater block. The repeater will look at an incoming data table and it will perform an operation on that single row and return whatever we tell it to. So we need to build a data symbol for it to consume. I know it will use a table inside, so I'll grab a table block, right click on it and convert it to a symbol. We'll call it get chords. And delete this instance. And for our symbol, we'll go ahead and use that. Now to set up this symbol more completely, we can click on the repeater and go into edit the symbol. And the only other block we need in here is map to table, which will display the single row of data that this instance of the repeater is looking at. So that's our table. We want to look at our output table. That was our generic table. So all we need to do is grab our lat long table and bind it to this table. So now when we look at this table, we see the coordinates. And we need to pass this data out of this repeater. So we're going to add some simple properties. We need our unique identifier, which will be our space ID string provided by the API. And we need the lat. And we need the longitude. So let's go ahead and bind our data points. So this one's our longitude. This one's our latitude. And our space ID is right here. All right. Go ahead and save our symbol. Now we see that we have an output table with space ID, latitude, and longitude. And our incoming data has the address and the rate information. However, what it does not tell us is it does not tell us if the space is available or not. To get that data, we need to hit another API. So let's go ahead and copy our loader and JSON blocks and grab the other API address that we're hitting. And then we can go ahead and remove this coordinates filter. And here we see we have space ID and occupancy state. So we essentially have three tables we need to combine together. So to do that, we will grab a multi-join. And we will add two tables. We'll bind in all our tables. And we will be searching on the unique ID, which is space ID, for that column to bind them all together. All right, so let's look at our output table to see what we're getting for our results. And we've got occupancy state, we've got address and rate, which are mostly what we're interested for this exercise. However, we know that the occupancy state API is not as complete as the other API, so we need to create a table filter to make sure that we are only getting ones with occupancy states, as we do not need the other one. I've seen this API also return spots with no addresses, so we'll also filter and make sure that we have addresses, which are in the block-based column. Let's leave this open so that we can see the names of our columns when we create our filter block. Make sure we don't misspell. All right, so we'll grab our filter block. Our output to our input. And we're going to be making sure the block face does not equal null. And that occupancy state also does not equal null. And this will return us a smaller table, which will be easier for our data to consume, as we don't need to consume and filter out junk data inside the UI. All right, so smaller table, everything's got occupancy state and an address. Let's go ahead and save our page. And now the next task will be to use this pre-created symbols to render these spots on the map. Okay, so to render these positions on our map, we are going to insert a map group. We also have a GeoJSON layer and a heat map layer available in ESRI Maps. However, we'll just be working with the map group today. So the map group is also a repeater, and it's going to be consuming data, and it will be displaying it using the symbol we've created. In this case, I've pre-created the symbol, which is this parking spot symbol. And now we just need to bring in the data. So our data will be coming from this table filter. So let's drag and drop. And our latitude field is a column named lat, and our longitude field is a column named long. So now, everywhere that has one, we'll have it. And it also is having a hard time knowing exactly which one is being labeled, so it's hitting our defaults in there. So we just need to open up our table and tell it which column. Get it from the render itself, the table rendered. And let's bind in point so that just the price. So now it knows which column is associated with which. So let's As we can see now, we're a little zoomed out. Let's zoom in again and reset our positions on the map. Do it manually. Okay, so we're going to put a nav bar in. So this looks like a pretty good place to save it, as our nav bar will occupy this side of the screen. So just for the demo purpose, let's go ahead and save our positions again. All right, and so now we've got our parking spots rendered. So now we're going to build our nav bar. So to build our nav bar, we need to insert a group on our map on our stage. We'll name this nav, and we will give it a vertical layout, and we will set its fill to white so we can see it. And now we want to position it. So we don't know what the size of the screen the user is going to have, so we're going to give it we'll give it a static width. But we will set its height to be 80% of the screen, and we will set top offset of 10%. And a left offset of 8%. And we'll keep it hanging nicely on the side. All right, so now we are going to insert a data grid into our nav, into the parent component. And a data grid is nice because a data grid will only render the data of the table that is visible in the group. So then that way, if you have a really large data set, it doesn't have to render as much data, and it will run more smoothly. So let's go ahead. Again, we're using the same data table. So we get our data. We can go ahead and drop that in. And it has some automatic presets that we need to change. So we're going to set the height to 100% of its parent, and the width and the height to 100% of parent. So we'll take whatever size is set by nav, and we will not have a header, so we set the position size to 0. And the rows, we will be setting the information in here based on the symbol. However, we want to set the height of each row, so we can go down here to position and size. We're going to want each row to be 150 pixels to match the size of the symbol we'll be placing. And for our column, instead of type all, we're just going with all, tries to render all the data of the table, but we just need one, so we're going to go with name. And all we need, now we need to create the symbol that will be rendered, which is already created. So we can go ahead and load it up, which is our spot info. And we just need to add a selector. Maybe in a column, let's say block face. And so now we're getting all the spaces. However, we can see that the width is not correct. Let's go down to the size of each column. It is currently set on auto size, but it should actually be preset to 250. So let's just set that to set it statically to 250 so we know it fills the space. And so now we can see the nav bar that also is displaying the same data. We want to set one more set of behaviors. We want to be able to click on a location and automatically scroll to the spot where you're in. Right now, if you click on it, The actions have already been created, but we just need to pass the information out of these symbols. So we can do that by editing the properties of the page. We will be adding a selected item. Save our page. So our symbol is now able to recognize these items, but as we can see as we select these, we do not have it moving automatically inside of our scroll area to where it is in the scroll bar. So to do that, we're going to go to our data grid. It's an advanced property, so we will search for scroll. So all scroll properties, we want to enable scroll feedback, and we're going to be changing our scroll Y location. And to do that, go ahead and open up our properties of our page. We're going to look at our selected item. It's being passed out by our symbol down there. And we're going to use the row number, because remember this is the same table that is rendering here, to discover what row it's on. And then set the position of the Y, the scroll bar, with the multiplication data flow. Let's go ahead and grab out the multiply block. We will grab row 25. We set the row height to 115, so we know it's going to be 115. And then we can pass this value to our scroll Y. Close our windows so we test functionality. Now you can see as we click, then it moves to that location on the scroll bar. One last thing we need to do is make this scroll bar look prettier. It's an ugly default black. So we'll go in here to scrolling, expand scrolling, go into our advanced properties, and let's go ahead and set it to a dark gray. For some reason the default is 100% zero opacity. It's a little dark, let's go a little lighter. Okay, and now let's set the thumb to the same so we don't have that little outline. And there you go, one parking application. Let's save our page, and now you can see the different positions. All right, I hope you enjoyed that little video, and have a good day.